breaking down the fear factor for KPIs, and also just how what kind of a tool they can be used to strengthen your company's bottom line and culture.
Yeah, and it's interesting when you start using them. It's great because all of a sudden you're starting to expose either how your process is doing or what your outcomes look like. So we want to take the next step, because once you start getting a whole bunch of numbers, it's like, well, what does that tell me? So I want to share my screen, Brian. I want to show you some.
Oh, you're
the
going to
power
dive
of
right
a,
into it.
we
Go
we
for
are.
it, man.
We're
No.
not screwing around today, dude.
Oh man, I guess not. Take the reins. Go for it.
All right, you see what I've got laid down here?
Yes. Yeah, I do.
All right.
So what you're going to be doing is you're going to be taking this to the next level. We're going to be talking about really how KPIs are not, last week we talked about just measuring them, the impact that they can have. And now you want to really dig into basically just a few of the good things, but also, hey, stay away from a couple of these errors that we can often find when we're implementing and practicing our KPIs, correct?
Exactly. So what I want to show is, so this is just an example. This is number of employees that are out sick. This is at a hospital. And if you just were tracking this number in a spreadsheet, you'd see anywhere from, I think, nobody out up to probably looks like 20, maybe 24 people out over time. So you'd see this, just a random set of numbers. So the first thing we should do is let's plot this out, plot the dots. Yep. So this gives you a visual representation of that same data. And it's like, oh, well, this is interesting.
Yeah. And for those of you that are listening, picture in your mind, I'm looking at a graph right now, picture in your mind a roller coaster. And that's what this graph is showing here. Exactly. It is ups and downs and deep valleys and some, high peaks, and it'll get you sick just looking at it. So imagine that you're seeing that right now. So that's what Mike is showing us.
I love the color commentary, Brian. This is awesome. So the first thing we do is, Brian, when you look at this, so I've got this control chart. What would be a couple of things you might do to this to get an idea of what's going on?
Well, the first thing I would do as a business owner is freak out, because I'm like, there is no sense of stability. We have people showing up all this time. Then we have hardly anybody showing up. Everybody's calling out at the same time. And I'd circle the wagons and just completely flip my lid. So
you're perfect for this, man. I love this. So after you start, you throw up your morning coffee, then you look and say, well, maybe I should put an average in here, right? Put the mean in, and then maybe I want to put a trend line and see what's going on. And so what I love what you said is, I'm going to freak out because, this is unbelievable. Well, what if I said, let's add a little bit of more structure around this? And what this is called is an XM chart. And so what this does is just use basic statistics, and based on the data here, and we only have about 20 numbers, right, that we're using, but it does three things. It adds an average, it adds what's called an upper limit, and a lower limit. So it bounds all the data. And when you said you were going to freak out, what this tells us, the way this is laid out, because all those dots are between the upper and lower limit, you actually have what's called a predictable system. And what you're seeing in here is what's called noise. So this is a common cause system. Now, I don't know the size of this place, but let's assume they have, let's say there's 200 people working in this hospital. Maybe it's even a little bit higher than that. So when you put that in context, this isn't, a 50-person team. This is a pretty sizable operation. So when you see 25 people out, anywhere from 0 to 25 people out, it may not be that big of a cause for concern. When you
Right.
apply a run chart and then throw the upper and lower limit and the average, and you see all those dots are in between those two, we have what's called a predictable system. What does that mean? It means that going forward, I can predict that on any given day, we're going to have between 0 and 25 people out. And on average, it looks like around 13 people out.
All right. So let me stop you right there. And
You bet.
again, for those that are just listening and not watching on our YouTube channel, what Mike created was basically 3 lines. So if you're picturing a road, you have your left-hand lane line, your right-hand lane line, and then you have your double yellow line in the middle. That's what we have here. And then we have dots all throughout the throughout this chart here. And Mike, when you say the upper limit and the lower limit, what you did was you created a buffer zone between the highest amount of people that have been called out sick and the lowest, correct? That's what
Yeah.
that is. And so immediately I am feeling more at peace. I have not fired the HR person. I have thrown my coffee, but I am now in the process of wiping it off the wall, and I have calmed down. My pulse rate is back to Hannibal Lecter level, and so I'm feeling pretty good. So this is good because it shows that there's some parameters, and we're not completely out of whack. So go ahead.
Yeah. The other way to look at it is if you put it on it's laid it down flat and figure a 4-lane highway. If this is 2 lanes going one way, those upper and lower control limits are the guardrails, and the average is the center line. And so if I'm veering across the center line, the police won't like it, but I'm still making forward progress, and I'm not running into those guardrails. So to your
Right.
point, without applying, and this is a very basic statistical tool, without applying this, you will freak out because if one day I have 0 and then the next day I have 15 people out, right? I'm going to go, oh my gosh, what's going on? What this says, and here's the beautiful thing about this: you could use this with your resting heart rate, your weight, ketones. You can use it personally. You can use it at your business. You can use it for KPIs, metrics, any data that you have. You can apply this XM chart, and it will give you this graphical representation. So what you do with this is continue. So what this says is there's nothing to do. The system is in control. There's nothing to do here. You should not try to influence the behaviors that are existing here because this is normal. Now let me show you when it becomes.
So I like this because again, this is something that we talked about at the last episode, where KPIs are so influential in minimizing our emotional overreactions and the emotions, good, bad, or indifferent, that we have so many of them during our typical work day. And this is great because this just hammers down deep into this. And it's like,
Right.
okay, basically, don't be emotional. And then when is there a time that we need to take action? So this is great. And this chart here shows there is a deviation that has gone out of the parameters that you've set up. Now, Mike,
So
let me
here's
just ask you this quick question. When and how do you set up those upper and lower levels? I get the medium part, but how do you determine those? And does it depend on the thing being measured?
So right. So we'll post in the description 2 different sources of tools to use where all you have to do is drop these numbers in. Just drop the dots in. The upper and lower control limit and the average are calculated based on your data. So you don't even have to create the spreadsheet. You don't have to build the calculations. We'll provide you a link. That link will allow you to download a spreadsheet that has all the calculations in it. So all you do is put your numbers in, and it will produce this graph for you with your numbers.
Wow. Awesome. Awesome.
Yep.
Is it usually, give me a hint, is it usually like a percentage of the upper and lower? Like, is it usually a 10 to 15% buffer zone, or how have you
Well, think
seen it?
about, if you think about statistics, right? If you think about a regular distribution, a bell curve, right? If you put this on its side and did a bell curve, essentially it's saying as long as those numbers stay within plus or minus 3 sigma, and so we've got to get, so we want to separate standard deviation from a sigma. They're close, but in this case we're using what's called a sigma. So it's a calculation of how far out those points are from the mean, and as long as it's plus or minus 3 sigma from the mean, so the data itself is what, put it another way, the graph is created by the data that you put into it. So every graph is going to look different, and the graph will adjust, the X and Y axis will adjust based on your data. But as soon as you put the data in, as soon as you put 5 of those points in, it's already starting to calculate the mean, the upper and lower control limit. And as you add more information, right, it'll continue to adjust based on the data that's coming in. Does that make sense?
Yeah. Yeah. And I guess the next question is, do you, when you start plotting these out and calculating it, and you see a special, a signal or a special cause, as you have here on the chart, where you have an outlier, boom, it pops up either lower or higher, doesn't matter. At what point do you start to take action, or just say, hey, that's just a blip on the radar? Listen, we're not going to fire any nukes off. That's just a bunch of geese.
Dude, you are such a good straight man. So this was a hypothetical, this signal, this special cause, but this was the beginning of COVID. And so this is being tracked every day. So the more frequent you track the data, the faster you get feedback on what's happening and whatever you're measuring. So to your very point, as soon as you get to what's called a special cause, meaning we had a point that came outside of the upper or lower control, you need to ask the question, what has changed? Something happened, because we would expect the numbers going from 0 to about 15, or excuse me, 0 to 23, would you figure something like that? It is now outside of that. So when we talk about signal versus noise, prior to this new point, that was all noise, because all the data you were seeing and the results were part of a normal cause or a common cause system, meaning there's no special cause. Now we have it. And this is the time when you look and go, oh, now it's time to respond. So to give you a good example, Brian, in my past career, we charted everything. And before I was aware of this tool, we would say, hey, if I want a 98% line fill rate in a distribution center, what is a number that, if it's below that, how far below does it turn it red? So a lot of times you'll use KPIs, and you'll do either red or green, or red, yellow, green. If my target is 98 and I have my data coming in and I'm around 98 periodically, when do I start to look at a signal? Where is a signal? And in my case, it would have been, well, I'm just going to draw a line and I'm just going to eyeball it and say, I think this is the lower, and I never called it the lower limit, but I said, I think this is the lower limit. So if it goes below that, I want to do something about it. This says statistically, it could have been way lower than that. It could have been 96, and you wouldn't have to worry about it. So the nice thing about this is just using very basic statistics. And this has been around for 100+ years, Brian, this concept. In fact, this was originally used when Bell Telephone was starting to build, when the telephones first became a thing in the United States. This tool was used when they were building telephones. And this has lived on since then. And it's still as valid as ever, because it's just basic statistics. So in this case, we're saying we need to do something about this. So this is a special cause. Now, what's interesting is, I'll give you another example.
All right, so take a step back just for a second, because not everybody's a statistician and not everybody has charts that they like to write in their free time, unlike you, Mike. So tell us, just define again for us what signal is and differentiate it between noise, because you've used
Yep.
both of those.
Sure.
And those are a little bit different.
Yep.
You know, yeah.
They are. So if I go back to this original chart, so this is the first time we said let's not only do a control chart, but let's apply the XM. Let's apply our data using an XM chart. And so noise is what's called common cause, and what you're seeing is every dot is between the upper and lower limit, and as long as they stay in that zone, Brian, you have a process that's predictable, and it's got what's called common cause variation, meaning it's got normal variation every day, just normal, as long as it stays in there. But then we said, hey, we interjected and said, we've added one more point. So this is the same exact data, except for let's call it the 21st point. The 21st point just exceeded that upper limit. That is now a signal. So anything between the upper and lower control limit is noise, meaning you can ignore it. There's no special cause. Anything that goes outside of that bound, upper or lower bound, now we want to take a look and say something happened yesterday that we should take a look at and see what caused that to happen.
I like it. I like it. So ignore the noise, but the signal needs to be something that is going to spur you on to action. So
Exactly.
you have your area of inaction, but simply measuring and plotting, and then you have your action area, which is when it falls outside of those parameters that you have set up. Fantastic.
Exactly. So that's what they call rule number one. Anytime you have a point that falls outside of the upper or lower control limits, that's a signal. All right. So rule number one is if you see something that falls outside of that, that's a signal. We should address that. Here's another one. This is the shift in the data. And if you see, the green line is the average, and then the red line is the lower process limit. If you see 8 successive data points that fall below the average in a row, that's a signal. This process has shifted. Something has happened. So that's a new signal. So the rule one was based on the signal, anything falling outside of the natural process limits. Rule two is if you have 8 successive points that stay below the mean, meaning they're on one side of the mean, either above it or below it, and stay below that, you start getting 7 or 8. Now you want to take a look and go, something has changed, because if you see this earlier data, right, we're back and forth, above and below the mean, above and below the mean. Now all of a sudden, we're getting points that are 8 successive points that are below the mean. That's telling you that's a signal. Something's happened. So now something shifted, and now we're seeing a lot of data coming in all below the average, which again, over time would pull the average down. This has been developed over decades and decades of use.
Is it
And
always
so,
8 or generally 8?
yeah, if you start to see, 5, 6, 7, you could probably start going, I think there's something going on. But they've arrived at, if you see 8 or more, that's when you should take action. Now, for me, if I start to see the 5 or 6 there, I'd probably go, I could start asking around.
Yeah.
Right. But the idea here is you could put so many rules on here that all of a sudden everything's a signal. And the idea here is we're going to have 3 very simple rules. You're outside of the process limits. You're staying on one side of the mean for 8 successive days or weeks, whatever it is. Does that make sense?
Yep.
Yep. And again, if those points were above the mean, same thing, right?
Yeah.
You get 8 of them. You've got a shift in what's going on. And then the third one is you have 3 successive data points that are running very close to either the upper or the lower control limit. So
Okay.
they're not even close to the mean anymore. And there's three of them, and they're closer to the upper or lower control limit or process limit than they are to the mean. So rule one, we're falling outside of the upper or lower process limit. Rule two, we're staying on either side, 8 points on either side of the mean. And then rule three is we're seeing three successive points that are pushing either the upper or the lower process limit.
And
Those are
then
the signals.
okay. And then with those signals, you get one, maybe whatever rule number two, you get you see, I got 8 below the mean. Then what do you do? What does that indicate that you have to do? Take
So then,
action or change your
yes,
chart or what?
yeah. So we want to be careful. So this is what's called um, one. If you don't understand variation and you don't understand this statistical presentation or representation of the data, when you see a swing in data, like you said, it's like a roller coaster. You would start what they call tampering with the system, because you would think that going from 0 people to 15 people gone in a day is a catastrophe, right? It's like, we got to do something. And so what you'd be doing is you're tampering with the system, because the system's giving you this output very consistently. So anything that falls in between there, don't tamper with it. Now, if you want to improve it, that's a different animal. But if you're trying to go in there and saying, I'm going to go and fix this and try to find out what the cause is, there is no cause. It's all common cause. So what was the original question again, Brian?
Well, just when you encounter rule 1,
Hmm,
rule 2, rule 3, what do
right.
you do? Do you change a chart or do you change a system or
Yep. Yep. So then that's when you first start asking the question, what's going on? So you don't want to change the system yet. You want to go and find out what happened, because when this thing happens, it means something outside of the process or system is having impact on it. And if you remove that from the system, it would go back to the norm, and everything would go back to noise. So the cool thing is, and we'll talk about this the next time about how to do improvements. If you can show, and I'm going to go back to the charts again. If you can see this going on, Brian, this is a process that's in control. This is a process that you can say, hey, let's start trying to make improvements to this process. If you have data like this, the last thing you want to do is start trying to make improvements. What you want to do is solve the problems that are driving these unusual behaviors. Take care of those first. Find out what's causing that, fix it. Find out what's causing this, fix it. Find out what's causing this, fix it. It gets everything back to normal, back to noise. And then now you have a stable system again. So it's interesting, when you first start doing these KPIs, you should see some of this going on. And the first, your first gut reaction would be, I'm going to start fixing stuff. Well, yes, but you're going to fix whatever caused this to happen. This, whatever triggered the rule. And the cool thing is, if you're measuring this daily, and you even may show up the same day instead of waiting until the next day, when you get the data. If you see it happen, you can say, oh, here's what happened. We had a door fly open right off our manufacturing floor, and we had sand come in, and it actually hit our printing press and caused an issue with the press. Is that part of your system? No, but it's a factor. That's a signal saying something happened. So if somebody said, yep, got that, we found a way now that door, we were having a problem with the door, we have a way to keep that locked during the day, we fixed that. Now we'll just let it run its course, and you'll see that data blip is gone, that special cause has been removed, and you're back to normal. So now the printing press is running and I'm not having any issues. So what you typically see is something's happening. It could be like or you could have a commercial printer, and let's say you're starting to see these successive points. What you could have is, you could have an issue with color. One of your inks are starting to get a little low, and so you're starting to see a slight shift in the color that's represented, and it consistently is degrading. It's still within the zone, right? It's still within the upper and lower control limit, but it's starting to move on you. It's like, I think we should take a look at that because we've seen too many days where the ink was just a little bit lighter than normal, and it's sustained now. So let's
Right.
go back in and take a look. And we either it's like the old days, right? You take your little inkjet cartridge out and you shake it up,
Yeah.
throw it
Yeah.
back in, and you hope that works. So
Now, this is great because I mean, I'm even thinking of, smaller businesses, how they could use it. I mean, this is fantastic for measuring and improving your customer service aspect. Right off the bat, one of the simplest things you could do is like how many rings before the phone is picked up, how many minutes before an online order is verified and validated in store to communicate with the customer. These are all things that are okay. This is great because once you start plotting these, then you can get a great average and say, guys, here's what we're going to do. We're going to shoot to improve this aspect. Why did we have this outlier here? Well, it's only when we're short staffed, or it's only when this person is in charge, or what have you. So it allows you to really clearly communicate where there is an issue that is undeniable. This is great.
yeah. Now that was a good point, Brian, because you could have data. Let's say you're open Monday through Friday, and every Wednesday, and you're rotating supervisors, and every Wednesday you see a blip in the data. Now that's not going to show up. Let's say I have a full month in front of me, so I see 4 Wednesdays, and every Wednesday I see a little blip up, meaning there's some improvement. Now there's not a rule for that, but when you look at that visually, you go, "What happens on Wednesdays?" Well, that's Mary. So Mary comes in. Oh, Mary used to run that piece of equipment. And when she was like the best we had, right? And we made her a supervisor, of course. But when Mary comes in and runs that, we see a blip. And so it's not again, it's still considered noise, but you can start to see just doing this visually, graphically, you can start to see other kind of patterns that are happening, and you can ask the question. So the fun part about these are, if you update this and then post this on the wall, to your point, Brian, every morning, and you can say, here's the data from yesterday. The first question I'm gonna look and go, do I have a signal? And people look around and go, oh, no signal. Cool. Now there's additional that we'll show next time when we talk about doing improvements. There's a R chart that goes on the bottom of this that measures the distance between points. And that's another signal. So if you look at this one here, right, that rule 1 that got triggered, and then it shoots way up, almost to the upper process limit. If that rule 1 point was just above the lower process limit and then it jumped, that would be a signal, because that's a big move, right, from one point to the next. So this is called the XM chart, and XMR chart also tracks the movement between points every day. So that's an additional point that can show up. But just this alone, these 3 rules with an XM chart will completely change the way you look at metrics and KPIs and how you work with your team to decide, is there a problem that we need to solve here? And if you take out, again, if you get back to the...
And you said, when you say XM chart, is that a specific chart, or is that just what we're looking at with the upper and lower limits?
That's what this is called. This is called an XM chart. Yep.
Okay, so upper limit, lower limit, and median.
And mean. Yep.
Mean.
Yep. And so so like I said, if things are going good, like here, and you say, hey, let's start making improvements, beautiful. So you want to go from this kind of data, right, to this. So you want to get rid of the signals, get back to a predictable system. And now when you talk about tinkering with the system, I should say tinkering, when you want to start talking about improving the process or improving the system, now you can use methodologies to go and say, okay, let's start looking at ways that we can improve this. And that's the great thing about when you hear about continuous improvement, you hear about lean, those kinds of things, Brian, that's what they're talking about. can you improve this? One is you could lower the mean over time. If that's, so if less people being out sick is good, then part of it is just you can bring the mean down, or you can reduce the variation, meaning you don't have as many swings. So the tighter that number around the mean, right, the tighter the process control. So this, which is weird, is if somebody look at this and go, would this be considered a predictable system, a system that's in control? And without putting the upper and lower process limits on it, you'd say, my God, that looks crazy. But as soon as you apply it, it's like, no,
Right.
statistically
I love
speaking.
it.
And the great thing is, as leaders, we can look at this and say, this is a predictable system. So I know tomorrow that I could see anywhere from 0 to 23 people gone.
Wow,
If I
that's great.
see higher than that, I know that I need to take a look at it. So this is what gets you away from, to your point, just using KPIs reduces the emotion, start to talk about what's going on in the system, stop pointing fingers at people, what's happened. Now we're applying just a very basic statistical tool on top of it to say, when do I care? When do I have to worry about that data point? Is that a signal that I have to go after or not?
Yeah, and I love the fact that this just clearly visualizes it, makes it very easy to visualize for everybody, all the teammates, to be able to say, oh wait, what happened here? What happened here? And the best thing is, don't point it out. Let them point it out and be like, that's a great question. All of a sudden, now they have buy-in, and they're like, well, I don't know. Let me just check on that. Could that be this? Could that be that? And then they start trying to problem solve things. And this is great. And because, it is, like you said, it is a perfect way of building on the KPIs that we have said to continually minimize our emotional overreaction and to just continuously improve. Okay, what can we do to tweak this? I don't really know if we can do that. Okay, well, then all of a sudden brainstorming happens, good things happen. So this is great. And this can be applied on just about any level, anything that can be measured, like you had said before. So the biggest thing is, hey, start getting and implementing some of the KPIs, determine which ones you want to focus on. Don't try to focus on everything. This is great. Get the KPIs, start measuring it, start tracking it, and then have some fun with it. This is fun. Anytime you can make these changes is fun. And then all right, no reason to freak out here. I won't throw my coffee against the wall. This is all part of it.